Hello everyone, welcome to another video lecture of Mathematics Solution channel. Today we are going to discuss about how to solve integral sin power nx dx, integral cos power nx dx and integral sin power mx and cos power nx dx. This problem I am going to solve by using the reduction formula, and before that, what is meant by reduction formula? Well, a reduction formula is a recurrence relation that reduces the terms, that is reduce the higher degree terms in the lower degree terms. Then by using the recursive formula, finally the higher degree terms converted into either degree 0 or 1. So using this we can easily complete the integral process. So that's the reason why we are using the reduction formula. And first thing, I'm going to take integral sin power nx dx. So let us consider in is equal to integral sin power nx into dx. I think you know I represents integration and n represents the highest degree here. So in is equal to integral sin power nx into dx. Now if you keep this term as it is not possible to find the solution. So that I am going to split this term as a sin power n minus 1x into sin x into dx. Now this will become u into dv. And now which one is the first term and second term? Let us consider this is the first term and this is the second term. Now we are going to use the by integration by parts. Now this will become integral u into, that is sin power n minus 1x into v. This is dv value, so v will become minus cos x. Then my integral v into du minus cos x, and the differentiation of this first term will become n minus 1 into sin power n minus 2x, and sin will become cos x into dx, and which is equal to minus sin power n minus 1x into cos x, and we have here is 1 minus, here is 1 more, so minus into minus will give plus, so plus. And we have n minus 1 is constant, take it out, so n minus 1 integral cos x, here is cos x, so that can be written as cos square x, so cos square x into sin power n minus 2x into dx. Now minus sin power n minus 1x into cos x plus n minus 1 integral. Now this completely it is a sine value, that is sin power n. So I am going to write this cos square x in terms of sin theta. So how can we write? That is 1 minus sin square x into sin power n minus 2x into dx. Here it is minus sin power n minus 1x into cos x plus n minus 1 into integral. Just multiply here 1 into sin power n minus 2, this sin power n minus 2 in x dx, and we have one more minus sin power 2, here is sin power n minus 2, we have base are equal, then we can add the part, so this will become sin power nx into, so we'll write here into dx, and then just operate this n minus 1 and split the integration. This will become, so sin power n minus 1x into cos x plus n minus 1 into integral sin power n minus 2x minus again to dx minus n minus 1 into integral sin power nx into dx. Already we know if it is n, then we can write in. If it is n minus 1, we can write in minus 1. Similarly, here we have n minus 2. So this term can be replaced as in minus 2. Already we know integral sin power nx dx can be written as in. So that I can write minus sin power n minus 1x into cos x plus n minus 1 into in minus 2 minus n minus 1 into in. Here it is in. Actually we need to find the in value. If you look at the right hand side, and the right hand side also we have some in. So bring all the in one side, what will get? So this will become in plus n minus 1 into in is equal to minus sin power n minus 1x into cos x plus n minus 1 into in minus 2. Simplify this term, what you will get? Here it is in plus n into in minus in is equal to minus sin power n minus 1 x into cos x plus n minus 1 into in minus 2. So these two will get cancelled. We need to find in. Operate 1 divided by n on both sides. You will get minus sin power n minus 1x into cos x divided by n plus n minus 1 divided by n into in minus 2. So this is the reduction formula for sin n. Now we need to find what is the solution for the integral 0 to pi by 2 sin power nx into dx. Again we will consider as in, right? Already we know is integral sin power nx dx. If you take the limit, you will get the solution. So we have the solution, that is minus sin power n minus 1x into cos x divided by n, and the limit varies from 0 to pi by 2 plus n minus 1 divided by n into in minus 2. Now substitute 0, sin 0 will become 0, and if you go to cos pi by 2, this also will become 0, so the entire term will become 0, and finally we have in is equal to n minus 1 divided by n into in minus 2. Now we need to find what is the in minus 2, because we need to find the solution of 0 to pi by 2 sin power nx dx. That value is in. In the right hand side also we have some in, right? So we need to find it. So this here I am going to use the recurrence relation. So what is mean by that? Just take it as equation number 1. Now replace n as n minus 2. What will you get? in minus 2 is equal to n minus 3 divided by n minus 2 into in minus 4. Now we got the n minus 2 value. Just replace in the first equation. The equation will become in is equal to n minus 1 divided by n minus 3 divided by n minus 2, then in minus 4. Again in the right hand side we have some in. Now we need to find the in minus 4. So that in the first equation I am going to replace n as n minus 4. That will become in minus 4 is equal to n minus 5 divided by n minus 4 into in minus 6. Now substitute this value in the second equation. So what you will get? In is equal to n minus 1 divided by n minus 3 divided by n minus 2, n minus 5 divided by n minus 4, then in minus 6. If you proceed like this, then next step you will get in minus 6. Here you will get n minus 7 divided by n minus 6. So it is not possible to proceed all the steps. I am going to consider some particular value. Suppose if n is equal to odd value or n is equal to even value, what will happen? Now I am going to consider, let us take n is equal to some 6 and here it is n is equal to some 5. Now substitute here I6 is equal to 6 minus 1. So here it is 5 divided by 6 and 6 minus 3. So this will become 3 by 4 and this will become 1 by 2. Now listen, here we have completed 1, 2, 3, 4, 5, 6. Remaining we don't have anything. Let us take it is I0. And similarly, let's go with the n is equal to 5. I5 is equal to n minus 1. So 5 minus 4 by 5 and 2 by 3. If you substitute one more term, so this will become 0, correct? So 5 minus 1, here is 5 minus 3, then 5 minus 5 will become 0. If you substitute 0, the entire term will become 0. But I took n is equal to 5, I completed 4 numbers, remaining we have 1. So we need to find what is meant by I0 and I1. Already we know in is equal to sin power nx dx. If you substitute 0 here, what you will get? I0 is equal to integral 0 to pi by 2 sin power 0x into dx. We know anything power 0 will become 1. So here I0 is equal to pi by 2. After simplification, directly we will get 5 by 2. Similarly, here I1 we need to find. Then I1 is equal to integral 0 to pi by 2 sine power 1x into dx or sine x. We know what is the integration of sine x, that is a minus cos x. So minus cos x, and the limit varies from 0 to pi by 2. If you substitute pi by 2, this will become 0, and 0 minus of minus 1 will become plus 1. So I1 will become plus 1. Now the reduction formula for integral in 0 to pi by 2 sine power nx dx will become going to write here, that is in is equal to n minus 1 by n minus 3 by n minus 2, n minus 5 divided by n minus 4 up to we have finally it is pi by 2, right? And before that we have 3 by 4, 1 by 2 int I naught. Already we got I naught value is pi by 2. When or if n is even value. For odd value, n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, then up to we have here is 4 by 5 and 2 by 3 in I1. So I1 we got 1, so no need to write that, or if you want you can write if n is odd value. This is how we need to prove the reduction formula for sine power nx into dx. The same manner we can prove the integral cos power nx dx. Again finally we will get the same answer. In is equal to n minus 1 by n minus 3 by n minus 2 up to 3 by 4, 1 by 2 into pi by 2 if n is even. Similarly for n is odd you will get 4 by 5 into 2 by 3 into 1. So that will give the reduction formula for cos n. If you like this video, please subscribe my channel for more updates, and thanks for watching.